So number 1 wants me to write down the quadratic formula 3 times. So I'm going to write it down. It's x equals negative b plus or minus the square root of b squared minus 4ac over 2a. Good. I am going to write it once more, and then there's a song that goes with this. It goes x equals negative b plus and minus the square root b squared minus 4ac all over 2a. And then I'm just going to write it again because the paper told me to. Remember, knowing the formula is part of the question on the test. I made a mistake, and I did not remember that. And I will point out, I think I have a video of me singing the quadratic formula, so I will look for that and post it if I can find it. If not, you can rewind a bit and just, enjoy me singing there. Alright. This wants me to solve using any method I choose. Remember, we've learned factoring, solving by square roots, graphing the quadratic formula, and completing the square. So if I take a look at number A, letter A, I'm going to use the factoring method because there's no coefficient in front of the x. So I'm looking for two numbers that multiply to 30 and add up to 11. So the first two numbers I think of are 2 times 15. It gives me 30. 2 plus 15 does not equal 11. Then there is 3 and 10. 3 plus 10 does not equal 11. 5 and 6 does equal 11. So what I'm going to do is I'm going to write x plus 5 times x plus 6 equals 0. And I will point this out. I could have used the quadratic formula here, and it should still work out to the same answer. In fact, graphing, completing the square, all the methods except for solving by square roots will work on this one. Okay. Then I take each of my factored pieces and I set them equal to 0. And then I just solve for x. So on the first one, I subtract 5 on both sides, and I get x equals negative 5. On the second one, I subtract 6 on both sides, and I get x equals negative 6. So there are two answers. Okay. Part of the question stated to make sure I chose what method I chose. So this one, I chose factor. Okay. On B, I am going to choose the quadratic formula. That was the one at the top of the page. So I'm going to label my A, B, and C. I have negative 2 for my A, 3 for my B, and negative 1 for my C. So I'm going to plug those in. I have x equals negative, and then I'm plugging in 3 for B, plus or minus the square root of 3 squared minus 4, because that's part of the formula. My A value is negative 2, and my C value is negative 1 over 2 times A, so 2 times negative 2. Then I want to simplify my equation. So I have negative 3 plus or minus the square root. 3 squared is 9. Negative 4 times negative 2 is positive 8 times negative 1 is negative 8. Then I have 2 times negative 2, which gives me negative 4. I drew the square root symbol way too large. Then I want to simplify. I have negative 3 plus or minus the square root of 1, and I get negative 4. I can take the square root of 1. This was something I saw on a lot of tests, is that people would get to the square root of 1, and I saw it on homework assignments too. Square root of 1 is 1, because remember 1 times 1 equals 1. So then I am going to do this over here. I have negative 3 plus or minus 1 over negative 4. So now that I have this, I can split it up into two separate equations. Okay? I can have negative 3 plus 1 divided by negative 4, and I can have negative 3 minus 1 divided by negative 4. So negative 3 plus 1 equals negative 2 over negative 4. That simplifies to 1/2. On the second one, I'm going to move my mouse off the screen. I get negative 3 minus 1, which gives me negative 4, divided by negative 4, which gives me positive 1. And I want to say I used the quadratic formula. On this one, I could have also done factoring, but I would have had to use the AC method. Like I said, both methods would give me the same answer. Also, I guess graphing would work on this one too. Because they're nice whole numbers. Not nice whole numbers. They're nice numbers I can get decimals of. On C, I am going to solve by square roots. This is a nice factorable thing. It factors into a perfect square. 2 times 2 gives me 4, and 2 plus 2 gives me 4. So I'm going to have x plus 2 squared equals 49. And then what I'm going to do is I'm going to take the square root of both sides. I get x plus 2 equals plus or minus 7. I'm going to subtract 2 on both sides. I get x equals negative 2 plus or minus 7. Now since these are real numbers and none of them have imaginary parts or square roots, I'm going to split it up into 2 equations to solve. So I have negative 2 plus 7, negative 2 minus 7. The first equation gives me positive 5. The second equation gives me negative 9. Now, I could have solved this by subtracting the 49 over and factoring, because it would have given me x squared plus 4x minus 45. I could have solved by graphing if I got it equal to 0. I could have solved by using the quadratic formula again if I had set it equal to 0. All of these methods are valid and would have worked for this. And I gotta say my method, so I use the square root method over here. So moving on, this one only wants me to use the quadratic formula. So I first want to get this equal to 0, so I'm going to subtract 5 on both sides. Then I get negative x squared minus 4x minus 5 equals 0. I want to label my a, b's, and c's. My a is negative 1, my b is negative 4, and my c is negative 5. I'm going to go ahead and plug those all in. I get x equals negative, my b value, which is negative 4, plus or minus the square root of negative 4 squared minus 4 from the formula, times my a value, which is negative 1, times my c, which is negative 5, divided by 2 times my a value, which is negative 1. Then I want to simplify. So negative 4 gives me positive 4. Negative 4 squared gives me 16. Negative 4 times negative 1 gives me positive 4. Positive 4 times negative 5 gives me negative 20. Then I have 2 times negative 1, which gives me negative 2. Then I want to add the number, or subtract the numbers under my radical. So I still have the 4 on the outside, still plus or minus. 16 minus 20 gives me negative 4 over negative 2. Then I want to simplify my radical. Because it's negative, it's going to be imaginary, but I can take the square root of 4. That gives me 2. So I have 4 plus or minus the square root of 2i over negative 2. Then what I want to do is I'm going to split these up. I'm going to have positive 4 divided by negative 2 plus or minus 2i divided by negative 2. And this will give me negative 2 plus or minus 2i. Okay, and let me show you why I still leave the plus or minus at the end. Where did I put all my pens? Okay, if I broke this up into 2 pieces, if I had 2i divided by negative 2, it gives me, oh, dang it, it should have been just an I, because 2 divided by 2 is 1. If I had 2i divided by negative 2, I get negative I. If I have negative 2i divided by negative 2, I get the positive I. So again, I have the plus and minus answers. I just split it up over there. Okay? moving forward, it wants me to write this as a complex number in standard form. So what I want to do here is I want to first distribute that negative and then combine like terms if I can. I'm going to treat the i's like imaginary, like variables. So I'm going to distribute this like it's a negative 1. So I have negative 21 minus 3i, and then minus 2, and then I distribute over here, and I get plus I. Then I combine like terms, so I have the negative 21 and the negative 2. Those are both my real parts of the equation. I get negative 23. Then I have negative 3i and positive I, which give me negative 2i for my final answer. Okay. Number 5 wants me to multiply, so I'm going to FOIL here. I am going to start off by distributing my 3 to the 5. 3 times 5 is 15. Then I have 3 times negative 1, or negative I, which gives me negative 3i. Then I have, Then I have 2i times 5, which gives me 10i. And then let me find my curve really quick. I have 2i times negative I, which gives me negative 2i squared. Then what I want to do is I want to simplify from here. I will combine my middle terms. So I have negative 3i and positive 10i. So I have 15 plus 7i minus 2 times 9, 2i squared. Okay. What I want to do here is I want to then change the I squared. Remember, I squared equals negative 1. So I'm going to replace this I squared down here with negative 1. So I have 15 plus 7i minus 2, and instead of I squared, I'm going to replace it with negative 1. Then I want to multiply. So I have 15 plus 7i plus 2, because negative 2 times negative 1 gives me positive 2. And then I can combine the 15 and the 2 to get 17 plus 7i. Number 6, it's telling me a golf ball is hit from the ground and its height is modeled by the equation h of t equals negative 20t squared plus 130t, where t represents the height in feet of the ball after t seconds of contact. It wants to know the maximum height of the ball. So what I am going to do is I'm going to take my calculator and yes, going to go to y equals, I'm going to type in the equation, and instead of t, I'm going to use x. And then I'm going to go to graph it. Hold on. I did not type it in. Oh, I did type it in. Then I'm going to go, go back to the graph. Since I know it is a maximum, what I want to do is I'm going to go to second calculate or second trace. I'm going to go down to maximum. And then I want the cursor on the left side of the graph. So even though I can't see the maximum height, it's okay. The numbers at the end will tell me. So I'm going to press enter here. And I'm going to move the cursor until I see it again on the right line. So on the right side. Oops, I just saw it. I press enter twice. And it tells me my maximum as the x value of 3.25 with a y value of 2.1125. The y value is the height because it told me h of t represented height. So my answer here is 211.25, what was this measured in? Feet. Okay, it wants to know time in seconds. So if I go back, this would be my x value. So 3.25 seconds. And that's it for this question. Number 7 wants me to solve with substitution or elimination. I am going to do elimination. This is the one where I add down. So the x squared and the 6x do not combine. So those get written separately. The y's will cancel out. Then I have negative 7 equals 2, so I'm going to have negative 5. Then I want to add the 5 to both sides to get it equal to 0. I get x squared plus 6x plus 5 equals 0. This is something I can factor, so I am going to factor. You could do whatever you want. Any of the methods we've learned will work for this problem. I come up with 1 and 5 multiplying to 5, and 1 plus 5 equaling 6. Okay. Then by the zero product property, I'm going to take this and split them up and set them equal to 0. I have x plus 1 equals 0, and x plus 5 equals 0. Then I solve each equation. I get x equals negative 1, and x equals negative 5. I am not done, because I need to get coordinate points as a solution to my system, because I had x and y show up. So what I'm going to go do is I'm going to go plug back in. I can pick whichever equation I want. I'm going to pick the top one since it doesn't have squares that I have to deal with. So I'm going to plug in negative 1 for the first equation, the first equation I solve, I'm going to plug in negative 1. So I have 6 times negative 1, which gives me negative 6 plus y equals negative 7. I want to add 6 to both sides. I get y equals negative 1. So my first coordinate pair for my answer that I'm going to get is going to be negative 1, because that's the number I plugged in, and then comma negative 1 again, because that's the number I got out when I plugged into the equation. So it's the first one. Then I'm going to plug in negative 5 for x. So okay, 6 times negative 5 gives me negative 30. Then I want to add 30 to both sides. And I get y equals 23. This time my coordinate point is going to be the negative 5 I plugged in and the 23 I got out. Moving on. Number 8 wants me to solve by graphing, and it wants me to plot the graph and write down my intersecting coordinates. So what I'm going to do is I'm actually going to go on my calculator. I'm going to go to y equals. I'm going to clear out any equations I have there. And then I'm going to type in the equations that I want to graph for this. Okay, then I'm going to graph it just to see what it looks like. Okay, so the straight line is the top equation, and the red line is the second equation. Let me see if I can focus my camera a little bit. There you go. And then what I want to do is, so this is mostly on the right side of the graph, where the 2 points are going to cross. So what I do when I look at my table of values, I'm going to look for positive x values. So I'm going to go second graph, or second table. This will take me to my values. And notice, if I look again at the right values, right, positive x values, they are all going to fit on that graph I can graph. So what I'm going to start off by doing is I'm going to write down my table of values. I'm going to go from 1 to 5 for my x values. Did not draw this table long enough. Okay. Then I'm going to go plot these on the graph. So when I plot them, this is going to be my first one, the one with just the x. So I have 0, 1, or 1, 0, 2, 2, 3, 4, and 4, 6, 5, 8. Then I want to connect those. All I have is my phone. Okay. And then I want to go graph my red line, or red graph, which is the second equation. I have 1, 8. 1, 2, 3, 4, 5, 6, 7, 8. I have 2, 2. I have 3, 0. 42, 5, 8. Okay, so I want where it's crossing, and I should have noticed this when I was plotting. It's where the points were exactly the same for the y values. I have the point 2, 2, and I had the point 5, 8. Notice, if I look at my table of values, these are where the y values were exactly the same. This will always happen. But part of their points on your test are for graphing, so make sure you graph the graph too. Okay, number 9 wants me to solve it algebraically. So this one, I want to get all my pieces over on the same side. I'm going to add 48 to both sides. I get x squared minus 14x plus 48 is greater than or equal to 0. Then what I want to do here is I want to factor. I'm looking for things that multiply to 48 and add to negative 14. I'm going to have x minus 6 times x minus 8 multiplies to positive 48. Negative 6 plus negative 8 adds to negative 14. Then I take each piece and set it equal to 0 by the zero product property. I add 6 to both sides. I get x equals 6. Over here I add 8 to both sides. Get x equals 8. Then I'm going to draw my number line. I'm going to have the points 6 and 8. These are my test points. And, or these are not my test points. These are my boundaries. And then I want to pick my test points. So I want to pick something that is less than 6. I'm going to pick 0 for my test. I'm going to pick something in between, 7. And then I'm going to pick something greater than 9. Then I'm going to plug back into the original inequality I had up here. So I have 0 squared minus 14 times 0, and it should be greater than negative 48. So I have 0 squared, which is 0, minus 14 times 0, which is 0, still be greater than negative 48. 0 minus 0 is 0. 0 is greater than negative 48. I'm going to do the same thing with the number 7. I have 7 squared minus 14 times 7 should be greater than negative 48. I get 49 minus, I don't know, 14 times 7. 98. And it should be greater than negative 48. 49 minus negative 98 gives me negative 49. It is not greater than negative 48. So this one doesn't work here. And I'm going to do the same thing again for 9. So this time I have 9 squared minus 14 times 9. And it should be greater than negative 48. 9 squared is 81. Negative 14 times 9 is not a number I know. 126. And it should be greater than negative 48. I want to figure out what 81 minus 126 is. And I get negative 45. Remember, since I'm dealing with negative numbers, negative 45 is greater than negative 48. So this is true. The way I write my answer is going to be x is greater than or equal to 6. Or no, just kidding, less than or equal to, because it's on the left side. And the reason it has the equal to piece is because it had the equal to piece up here. Or x is greater than or equal to 8. These numbers came from my blue numbers that I got when I solved. And then deciding which way it went is when I plugged it in and tested to see. Okay. Number 10 wants me to graph the inequality. So what I'm going to do is I'm going to type just the equation into the calculator. Just the right side into the calculator. I have x squared plus 13x plus 12. I graph that. I'm going to zoom out a little bit. And it looks like it's probably on the left side based on the way that line's curving. But I just want to double check. It is. So then I'm going to go second table to get my table of values. Second table. Okay. And since it was mostly on the left side, I want mostly negative values. So I have x, y. I have negative 1, 0. I have negative 2, negative 10. I'm only going to pick values that I can mostly plot. I have negative 11, negative 10, and negative 12, 0. I'm going to go plot the points that I can. So I have negative 1, 0, negative 2, negative 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, negative 11, 10, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, wait. Okay, negative 12, 0 would be there. Then, because it doesn't have a line underneath, I want to use a dashed line to connect. And then I need to figure out where to shade. So I want to pick a test point. 0, 0 is going to be my test point. So I'm going to test 0, 0. I plug in 0. I have 0 squared plus 13 times 0 plus 12. 0 squared is 0. 13 times 0 is 0. And plus 12. I have 0 is greater than 12. That's not true, so I don't want to shade where 0, 0 is. I want to shade everywhere else, so I'm going to shade inside my inequality.